The diagram, not drawn to scale, shows the cross-section of two cylindrical jars, jar X and jar Y. The diameters of jar X and Y are 3D and D, respectively, as we see in the diagram right here. 3D for the diameter of jar X and D for the diameter of jar Y. Initially, jar Y is empty and jar X contains water to a height or depth of 4 centimeters. Determine in terms of pi and d the volume of water in jar X. We will determine in terms of pi and d the volume of water in jar X volume. There we have it highlighted. Determine in terms of pi and d the volume of water in jar X. Cylindrical jars. We are just highlighting that the jars are cylindrical because the shape of the volume that we have will determine the way that we find the volume. The jar is cylindrical. The shape of water in the jar will also be cylindrical. We have a cylindrical jar here and water is poured into it up to a certain height or depth. The water in the cylindrical jar, of course we know from science from an early age that water will take the shape of its container, and that is what we have right there. So the shape of the water in the container is also cylindrical. A cylinder is a prism whose volume is given by area of cross-section multiplied by length or height. Of course, we'll take a look at what we mean by cross-section, because as we have it inside of the statement of the problem, there's a particular defect that is going to be highlighted in this audiovisual. A cylinder is a prism with a circular cross-section whose area, which is that of a circle, is therefore given by the area of a circle. A is equal to pi d squared all over 4 or pi r squared. So the area will be pi d squared all over 4 or pi r squared, and that will be the area of the cross-section. Of course, the cross-section of a cylinder is the shape of a circle. Therefore, the area of the cross-section will be the area of a circle. And what do we mean by cross-section? The cross-section of a prism, or we will say that a prism is of uniform cross-section, which means that there's a particular shape that is present throughout the entire height or length of the prism. It is a constant. It is always that same size and shape throughout the length or height of the prism, and that is its cross-section. In this case, the cross-section is in the shape of a circle because the circle is present right at the base here, and it is the same shape if we continue throughout the entire height of the container and also the entire height of the water. What we describe as a prism, you can think of it like your bread. Your bread will have slices of equal size and shape. So the shape of those slices will be the shape of the cross-section of the bread, because a bread is a very close approximation of a prism because of its uniform cross-section, which is the slices of equal shape and size. Now, let us go back and see why we are highlighting the diameters here. Because the area is given in terms of diameter and also radius. So we have A is equal to pi d squared all over 4, or A is equal to pi r squared. So we are showing that the diameters are actually given, therefore we are required to use the formula involving diameter. Some students don't do that. Some students convert the diameter to radius. They never use diameter at all. They always convert the diameter to radius, and then consistently 100% of the time invariably use radius when they are calculating volume, or when they are calculating anything that has to do with radius. We will use the first one since the diameters are given in the diagram. So we'll use the first formula, which is the one that we have highlighted right there. This one. Cylinders have circular cross sections. The word in the statement is therefore incorrect and should really be vertical section. So we have the statement of the problem. Let us see if we can find that word. Here we have it. The diagram not drawn to scale shows the cross section of two cylindrical jars. A cylinder has a circular cross section. And right here we do not have a mere circle shown. Therefore, the word cross-section in the statement of the problem should not really be cross-section. It should really be vertical section. Because if the cross-section were shown, then we'll just have just a circle being shown. So that's a vertical section that we have there. In the formula, D is for diameter and R is for radius, as we have them right there. So we don't need to overemphasize. We know that from the discussion that we had previously. We will go straight ahead. We'll need to find the volume of water in jar X. And this is what we are doing. And we are going to express that in terms of D and pi, or in terms of pi and D. The volume of water in jar X is therefore given by area of cross-section times length or height. And the area of the cross-section is pi d squared over 4 times h. We are using that formula because the diameter is given. D in the formula is the diameter of the cross-section, which is 3d. It's given as 3d. The diameter of the cross-section is given as 3d, and you know exactly what we will do with that. We will substitute that straight into the formula right there. Also, the height of the water is given as 4 centimeters. Those values will therefore be substituted right into the equation that we have right there. There is your substitution. After substitution, we will do any form of simplification in order to write the volume of water in jar X in terms of pi and d. The fraction may be simplified by a common factor of 4. 4 is cancelled, and in the brackets, as we have that, 3d squared. The 3 will be squared and the d will be squared. Finally, 3 squared is equal to 9. And when we are expressing any algebraic representation, the pure number is called the coefficient, and it is always the prefix to the rest of the term. Therefore, 3 squared is equal to 9. 9 will be the prefix or the coefficient of the expression that we have right there. Rewrite the expression leading off with the numerical coefficient. So the numerical coefficient is 9, which is 3 squared, and we will begin with that. Therefore, that is your volume of the water that is in jar X, expressed in terms of pi and d. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.